Hi everybody, my name is Kingsley, and today I'll be talking about power series representation using algebraic manipulation. The first thing we should know about representing a function as a power series is the geometric series. And since the geometric series is a type of power series, we can use it to represent any function as a power series. So the geometric series is x to the n, and we can see that the equation for the geometric series is 1 over 1 minus x, and it converges when the absolute value of x is less than 1. So theoretically, we can take any function and put it in 1 over 1 minus x form, and then we can set it as a series and represent that as a power series. So let's go to example 2, which says, find a power series representation for 1 over x plus 2. And so the first thing we want to do is set it as close to this equation right here. And the first big difference we see here is that the x is the first term here when it's supposed to be the second term. So we can flip them around. So it becomes 1 over 2 plus x, so that the x is the second term in the denominator. And now we have to turn this 2 into a 1, and we can do that by factoring out a 2 from 2 plus x. And so we get 2 times 1 plus x over 2. But now we have a addition here when the equation needs a subtraction. And one way that we can rewrite an addition as a subtraction is by subtracting a negative of the same term. So now it becomes 1 minus negative x over 2. And now the final thing we need to get rid of here is the 2 in the denominator, since this one here doesn't have it. And we can act like 1 over 1 minus x over 2 is being multiplied by a 1/2, so we can just pull the 2 and the 1 out from here, and so we get this. And now we have our x term by itself, which we can now plug into a series by just putting it to the power of n, and we still have to keep this 1/2 out here. So now that we have our x term by itself, we can now find the regions of convergence. So we just set the absolute value of our x term, which is negative x over 2, is less than 1, and we can get rid of the negative here since it's the absolute value and it doesn't matter. And so since we know it has to be less than 1, we can put it in between negative 1 and 1. And to get rid of the 2 here, to find the values of where x converges, we can just multiply both sides here by 2. And so we see that for 1 over x plus 2, it converges when x is in between or equal to negative 2 and 2.